All right, let's talk about something every hardware hacker and network engineer runs into: the console port. You know, it's your lifeline when everything else goes wrong. But plugging into an unknown port can feel like a real gamble, right? Well, today we are taking all of that guesswork out of the equation. We're going to replace it with solid, safe certainty. Let's jump in.
I mean, we have all been there. You've got this expensive piece of gear, some random RJ45 console cable you found in a drawer, and your trusty USB adapter. You plug it all in and crickets. Nothing happens. Or, way worse, you get that little puff of magic smoke and that awful sinking feeling in your stomach.
And I'm not exaggerating here. One wrong connection can literally fry your USB adapter, the port on your multi-thousand-dollar switch, or, yup, both of them. It is such a costly, painful mistake, and it all comes down to a really simple electrical mismatch.
But here's the good news. You don't have to play Russian roulette with your hardware. There is a totally safe way to figure this out, and all it takes is a simple tool you've probably already got in your toolkit, a multimeter. With that, you can figure out the right pins and the right signal type before you ever connect a single data line. So let's break down exactly how to do it.
Okay, first things first, we need to get why this is so risky in the first place. The whole problem, literally the entire thing, boils down to two completely different and totally incompatible serial standards that just happen to use the same kind of connector sometimes.
And here they are, the two contenders. On the left, you've got UART TTL. This is the low-voltage language that all the little microcontrollers and modern embedded systems speak. We're talking 0 to 3.3, maybe 5 volts, super gentle. On the right, you have the old-school heavyweight, RS232. This is what a lot of enterprise gear uses, and it swings for the fences with voltages from -12 all the way up to +12 volts. See the problem?
This is what a nice, safe, modern TTL signal looks like on your multimeter: a gentle, positive voltage. This is exactly what those cheap and cheerful USB to UART adapters, the ones with the CH340 or FTDI chips, are designed to handle. They love this stuff.
And this is what an RS232 signal can look like. Take a good look at that negative sign. Pushing almost -10 volts into a tiny chip that's only expecting at most 3 or 5 volts, well, that's how you let the magic smoke out. This right here is the #1 mistake we are going to learn how to avoid, guaranteed. So, the million-dollar question: how do we tell these signals apart without ever risking our gear? Well, it's actually way easier than you think. It's just a simple two-step process with your multimeter. This is the secret sauce. Step 1, find your point of reference, your ground. Just set your multimeter to continuity mode, the one that beeps. Touch one probe to the metal case of the device, and then poke around the connector pins with the other probe until you hear that beep. Boom, that's your ground pin. Then, step 2, power the device on, switch your meter to DC volts, stick the black probe on that ground pin you just found, and then use the red probe to carefully check the voltage on every other pin. Now, here's your decoder ring for what the multimeter tells you. If you see a nice, steady, positive voltage, something around 3.3 or 5 volts, you can be pretty darn sure you're looking at a TTL transmit pin. But if you see a negative voltage, anything from like -9 to -12 volts, just stop. That's your red flag. You found an RS232 port. And if you're getting 0 volts, it's probably a receive pin or it's just not being used. Okay, so you found a pin with a voltage that looks promising, but how can we be 100% sure it's actually the transmit pin that's going to spit out all that juicy boot data? Well, we do a safe listen-only test. Now listen up, because this part is absolutely critical for safety. You are only going to connect 2 wires. That's it. Connect the ground pin you found to your adapter's ground. Then connect the pin you think is the device's transmit, or TX, to your adapter's receive, or RX pin. See what we're doing? We're only listening. You can't break anything by just listening. Now fire up your terminal software, set it to a common baud rate like 9600, and power up the device. And if you see this beautiful, readable text scrolling by in your terminal, congratulations, you did it! You have successfully, and more importantly, safely found the ground pin, the transmit pin, and you even figured out the right baud rate. You've totally cracked the code. 0 risk involved. Okay, theory is great, but let's see this method in the real world. I've got a console cable right here that came with a Fortinet FortiSwitch. Is it TTL? Is it RS232? Let's not guess. Let's let the multimeter tell us the truth. So after finding our ground connection, we just probe the other pins on the connector while the switch is booting up, and bam, look at that.
a rock-solid reading of negative 9.9 volts. We don't have to guess, we don't have to wonder. This one single measurement gives us the definitive answer. And that right there is the key takeaway. That negative voltage is the dead giveaway. It is the unmistakable signature of RS232. There's no gray area here. A TTL circuit will never, ever, ever produce a negative voltage. So we know for a fact our FortiSwitch port is RS232.
And knowing that tells us exactly what to do next, and maybe more importantly, what not to do. That little cheapo TTL adapter is the completely wrong tool for this job. It will almost certainly get fried. We absolutely must use a proper USB to RS232 adapter, because those are specifically built to handle these big, beefy negative and positive voltages without breaking a sweat.
So this whole process can really be boiled down to a super simple, repeatable safety checklist. Let's just quickly summarize the golden rules that are going to protect you and your expensive hardware every single time. Just think of this as your pre-flight checklist. Rule number 1. Ground is always your first connection, and it's your last disconnection. It gives everything a stable reference. Rule number 2. Measure, measure, measure. Always check the voltages on unknown pins before you even think about plugging in a data line. Let the multimeter tell you if it's safe. And rule number 3. Be super, super paranoid about any pin that provides power, usually labeled VCC. Never, ever connect it unless you know for an absolute fact that it's required. It's just way too easy to cause a short circuit. You see, this isn't really just about connecting to one switch. What you've just learned is a fundamental skill for hardware hacking, for reverse engineering, for professional repair. By just taking a few seconds to measure, you've turned a dangerous guessing game into a safe, reliable, repeatable process. So, I guess the only question left is, what are you going to explore next?